Hello, hi, Assalamualaikum. Welcome back to demonstration session for simple linear regression using R programming. All right. So in this video, I'm going to show you and demonstrate how to construct simple linear regression using R programming. So before we proceed, let recall some notes that we have learned previously. We have six assumptions in simple linear regression. First one is uh, can be summarized. This all six can be summarized into four equal assumption, which is line, L-I-N-E. L represent linearity, I independence, and normality and equality of variance. And then we need to remember in simple linear regression, there are only two variables. First, one dependent variable, and it should be continuous variable or numerical variable. And another one is independent variable. It should be continuous or categorical. So in this example, I'm going to use oxygen.sav dataset from this link. So you can get this link from the notes. Later on, you can browse the notes and download the dataset. So this dataset is about cardiovascular risk factor, and we have 1,000 males, and we want to study relationship oxygen consumption among the risk factor in this population. So the possible risk factor under consideration are the systolic blood pressure, total cholesterol, HDL cholesterol, and triglyceride. Right? So the research question, since we have four independent variables, and we want to study the relationship between oxygen and others for independent variable, and this is a simple linear regression, means that we're going to separate these one by one. Right. So the first research question is there any significant relationship between oxygen consumption and systolic blood pressure levels? Does the meaningful relationship between oxygen consumption and cholesterol level? Is there a notable association between oxygen consumption and HDL cholesterol level, and so on? So here is the research hypothesis. For example, let's say we're measuring the relationship between oxygen consumption and systolic blood pressure. The null hypothesis would be there is no significant linear relationship between oxygen consumption and systolic blood pressure. This is where the beta 1 equal to 0. And for alternative hypothesis, there is a significant linear relationship between oxygen consumption and systolic blood pressure. Right, so and so on. This is all the research hypothesis. Later on, you can read in the notes section. So let's begin how to perform a simple linear regression in using R. So now, first step, I would like to do a data exploration. So before we proceed with data exploration, we would like to import the data into our environment. So this is the link for the data. Let me copy the link. And we know that this is a .sav, means this is a SPSS data file. So to import the data from SPSS data file, I'm going to use foreign library. So if you don't have the foreign library, you need to install it first. So we're going to install this as a data one. So read.spss and input our link here. And then we want to convert this to data frame equal to true. And then I want to view six first observation in the data set. So I just put hit data one. So let me run this one. Wait, the read.spss, not SPSS. Right, so it should have this one. So this is the data. So the second observation, the second column is about our dependent variable. The third and fourth until fifth column is our independent variable. So then I would like to know what is the mean and standard deviation of each of the value. But before that, let me find out the structure of the data set. So we know that all the variable are numerical, then that's good. We're good to go. Right. So next, we would like to find the mean. Finding mean and standard deviation of each variables. Right. So maybe I'm going to use apply techniques to find mean. So finding mean, right? So we're going to use apply data one mean. So maybe I don't want the first and I don't want the first column mean, right? So we will get the mean value. So let's say I want to find the standard deviation, right? Apply data one and SD. So we will get all the summary of the data. This is the mean and this is the standard deviation. And if we would like to find is there any missing value, right? So we're going to use a library descriptor. If I not installed yet, so you need to install library descriptor. Install the library descriptor first, then we call the library descriptor, right? Then I want to use DS screener, right? Data one and negative one. So I would like to know, is there any missing value? So this is the code that I'm using, DS screener, and I'm removing the first column because I don't want the subject column, right? So there are no missing value in the data set. So this is part of the data exploration. So step 2, we would like to create scatter diagram and for each pass. That means that we want to know before we proceed with simple linear regression, we want to know is there any linear relationship between oxygen and systolic blood pressure, oxygen and total cholesterol, oxygen and HDL and so on lah. So here I'm going to use maybe library ggplot2, right? Because I like ggplot2 so much. I just want to show the first part, which is oxygen and oxygen consumption and systolic blood pressure. So I'm going to put it as a ggplot and data 1 AES. So the systolic blood pressure should be on X SBP and Y should be oxygen. O is capital, right? If you notice, this is the capital letter, right? Then I want to put as geom line, maybe geom point for scatter diagram. Size equal to 3. Background, I just want it to be gray, 88. And color means the background gray, right? And then PCH, the point pattern should be 21. This is good. And then I need to put labs, the title of the whole graph. This one should be a scatter diagram. Right. Next, the X value axis should be systolic. blood pressure, and y-axis should be um, oxygen consumption, right? Maybe I would like to use team minimal, and then make sure the title on the center, team plot title. So element text should be this just equal to 0.5 to make it the title on the middle. Okay, so let me run A here. So I should get the graph. Minute. Yeah. SBP. Is it capital S? Right. So SBP is start with S capital. So should have here. Yep. So maybe we cannot see much about the graph, kan? We cannot see the pattern whether it's but we can infer this is a negative relationship, right? But now just want to add some line which is geom smooth, right? Size equal to 3. Sorry, I'm just going to use method equal to lm, and then use the color of the line should be red. We try this one first. Okay. Yep, I got the line. So yeah, the title is too small. Maybe I make it bigger, 5. Yep, should be 10. I just try an error because I just want it, I need to make it um good enough display. Okay. Next, let's try this one in. So it should look nice. Now, I need to do the same for the rest. Oxygen consumption and total cholesterol. Right. So I just need to copy this one and paste again, and then replace this to B especially, and then this one X I need to make it as total cholesterol. Okay. Next, this one I need to represent total cholesterol. So I'm going to pause a bit after this to complete the codes, right? So okay, right. So I already finished up the coding for all variables. So now it's time to run the graph. So wait, I don't have the ggrid. So what I need to do is I need to install grid extra library. And then I need to call the grid extra library grid extra, right? And then need to run again. So now I have a very nice graph. Let me maybe I think I put it here and make it bigger. So yeah, so this is the graph. So notice this one I'm using the gray value. Maybe I can change this one to red as well. Just copy this one and put it here. And yeah, again, I'm going to run. Then I will get the graph nicely. Yeah. So this is the graph scatter diagram. We can see for oxygen and systolic blood pressure, it has a slight negative correlation. For oxygen and total cholesterol, it has a negative correlation. Maybe this is going to be very strong. And for high HDL cholesterol, it has a positive correlation, means that when the HDL cholesterol increase, the consumption of oxygen is also increased. When triglyceride increase, and the oxygen consumption also increase, but this is going to be a very slight, what we call association, right? So next, what we need to do after we know we have positive and negative correlation between oxygen consumption and systolic blood pressure, total cholesterol, HDL cholesterol, and triglyceride. So next step number three. Step number three, we're going to perform a simple linear regression, right? So highlight this one. So the first model will be oxygen consumption and systolic blood pressure. Right. So how to do it? Very simple. I just put it as I put it OS and systolic blood pressure. So I just put it this model as OS, and then I put it LM. This is the function to execute more simple linear regression. So if you look at the function, we going to use LM. RStudio will pop up the argument or how to use the function. So first, we need to put our formula and then our data, subset, weight, and age, and so on. So if you still don't really know how to use the function, you just type $LM on the console and press enter. It will lead you for the documentation, help document. So LM is used to fit a linear model, include multivariate ones. It can be used to carry out regression, single stratum analysis of variance, and analysis of covariance. This is how you want to use. This is the example, and this is the explanation of all the argument. And lastly, it will show us the example how to use it. So how to use it? First, we need to put the formula. What is the formula? Formula in R is start with y equal to x. So equality we replace by using tilde notation. So let's say I'm using data 1, oxygen. This is equal tilde data 1. And then I put the systolic blood pressure. And then after that, I'm going to do a summary or OS. OS is our model. First we feed the model, the linear regression model, and then I put it as I'm going to summary the model. So let's run this one. So we will get the model. Maybe I put it in the console so then we can see more clearer. Right. So this is the example. This is the result or regression, simple linear regression model for oxygen and systolic blood pressure. So as you can see, in simple linear regression model here, right, it already tell us the multiple R square. This is R square 0.03. It means that only 3.4% of the total variation in systolic blood pressure can be explained by systolic blood pressure. And then this is a ANOVA value, right, for simple linear regression. The p-value is less than 0.05. It means that the model is fit. And based on the coefficient table, we look at the p-value also says that the model is fit. The model is there is a significant relationship between oxygen consumption and systolic blood pressure. Right, this is the beta 1 slope. This is the equation where we have y equal to 47.3495, right, 95 minus 0.113638 with 4 decimal point x, right? So this is the equation for this model, right? So what's next? What we need to do? For this, we already know that this is the significant relationship between oxygen and systolic blood pressure. Next, we would like to get the confidence interval of the regression model. So how to do that? We just put confin OS. Right. So this is OS, and then we will get the confidence interval for the model. This is based on the coefficient table, right? So the confidence table intercept is 52 to 52. So this one, negative 0.15 until negative 0.07. Since the confidence interval does not include 0 in the interval, so then we can conclude that the model is significant relationship. So next, what step? Step number 4. Step number 4, what we need to do? We need to do a residual diagnostic to check the assumption of the model, right? So this is the crucial part. Since we already know that the model is significant, we need to check the assumption whether we can proceed with the final model or not. Right. First step is we need to check overall linearity. And then number 2 is equality of variance. Right. So now let's check for these two first. So to check the linearity, right, and equality of variance, remember in previous lecture I said that we need to check using a scatter diagram. So using a scatter diagram, the x-axis should be a predicted value and y-axis should be a residual value. So this is very simple. So let's use ggplot. Remember, to use ggplot, you need to load the ggplot to library. But before that, let's collect the data. We need to have maybe we don't need to collect the data also can, but we just put ggplot and then we put the data should be OS. Oh no, I think we need to collect the data for residual resid one. Maybe I put this as this one. So I put data.frame and then cbind residual. This is the residual value OS, and I need to select residual, and then predicted should be OS and fitted value. This is what we call as predicted or regression model. Then I just call library ggplot resid1. Right. Make sure the name, the data set name correct, and x-axis should be residual. Sorry, x-axis should be predicted, right? And y-axis should be residual, right? So I need to call geom point, right? And for geom point, I'm going to use pch equal to 21, and then size equal to 3.5. Background, maybe I need gray, very light one, gray 88. And the column, the border of the point should be a bit darker. All right, gray 56. Right. So next, I'm going to put elliptical line. So ellipse, and then I put LQY equal to 2, color equal to red. because 2 means that I just want a point line. So make it minimal, right? And then lastly, what we need to do is to put the title, title predicted versus residual or linearity and equality of variance. Right. So I think we will get this one. So now we have predicted and um, zoom this one. So I have a predicted and residual scatter diagram. We can see there are no pattern. We also have an elliptical shape in the diagram. So we can conclude that there are no linearity issue and equality of variance issue. Means that the equality of assumption is met and the equality of variance also met. Right? Right. So after that, what we need to do? The first two assumption we already checked. So next, we need to check the third assumption, which is normality assumption. Right. So for normality assumption, we will check by using a histogram, but focusing on the residual value. Right. So we need to make sure the residual value is normal distributed. So this is remember we already construct this data set. So this one should be AS will be residual, right? And then I'm going to plot histogram, histogram, right? And column equal to gray, borderline to be equal to gray maybe a bit lighter, darker, and then background or the color inside the bar should be more light. And then don't forget theme minimal. I like theme minimal so much. Then don't forget to put the title, GG title. So the distribution of residual values for the oxygen consumption and systolic blood pressure. Right. So let me find this one. Right. So why here. Yeah. So based on the histogram, we can conclude that the normality assumption is met since the histogram shows a normal distribution curve. We can confirm this by using a statistical test as well. Using statistical test. So how to use statistical test? Maybe I'm going to use using a library, not test, normal test, not test. So if you don't have, you need to install library, not test, right? So install the library, not test first, right? So then we can call the library, not test. So if it's too fast, you can pause the video and look at this the name of the test or package that I'm using. So residual, resid1, this is the name of data set, and then I call the variable, which is residual. Based on the Lilly 4 test, with this Lilly 4 test is a Kolmogorov-Smirnov test. It's actually an adjustment from Lilly Kolmogorov-Smirnov test. This data or result is consistent with the SPSS software as well. Based on the p-value, you can conclude that the normality assumption is met. Means that since the p-value more than 0.05, the data has a normal distribution, right? So since we already checked for LI, LE, and LEN, so maybe I is independent. That one should be settled during study design. So that is basically the assumption that you need to check. Right. So since all the assumptions are met, so the model is valid for prediction. So we can proceed for prediction. So then what we need to do, repeat the same procedure for all other variables, right? So remember, this is a simple linear regression. You need to do one by one. Okay. Right. So you can refer the next step in my notes. Right. I already provide the notes. You can go to the next step to see the notes. So I already construct the regression analysis, simple linear regression for systolic blood pressure, for total cholesterol, for HDL cholesterol. This is the same step. I just change the variable name. And this is how we present the result for simple linear regression, right? So we input all the variable into one table. This, of course, bear in mind, this is a separate analysis. This is the simple linear regression. We present the crude coefficient, 95% confidence interval, p statistics, degree of freedom, p value, and the r square value. Right. So I think that's all for this demonstration. So hopefully you can do some practice to repeat the same procedure for all other variable and try to do the presentation for of the analysis. Until then, we meet for the next topic, which is multiple linear regression. Okay, bye. Assalamualaikum.